Reams. Advent Code 2021, day 17 and day 18, 55 minutes. I don't have the quality options tonight, but I'm not going to let that bother me. Let's just begin. I need to catch up. I have 55 minutes until puzzle 18 unlocks. I'm wondering if that'll be enough time to do puzzle 17. We can always have hopes and dreams, right? So let me just get this set up. While I'm at it, I'll just do day 17 and 18. Actually, you know what I'm going to do? I'm going to prepare day 17 and then add day 18 as a copy of 17. Alright, so 17, get rid of this. Make that a 7. Delete a lot of stuff. Make this a to-do. Copy. Paste. Alright, and then let's just copy that to day 18. Make that an 18 there. Hey there, Devil Squirrel. How are you doing? Was trying to catch up. I didn't stream yesterday, so I gotta do day 17. And then day 18 unlocks in a little under an hour. (17, 18). Mod day 17. Mod day 18. Maybe next year I'll make use of some framework which lets me do away with this boilerplate. I kind of like the boilerplate though as a means of like getting warmed up. 17, 18. Get the benchmark out of the way. How is everybody doing on this Friday night / Saturday morning / Saturday afternoon? What are the time zones might there be? Maybe a Friday afternoon for people west of me? Okay, so need a terminal. 2021 cargo run 17.1. And 18.1. Not yet implemented. Okay. Big breath. So Advent code, Advent calendar, programming puzzles from December 1st to 25th. You get 2 puzzles each day. The day 18 unlocks in 52 minutes. I didn't do day 17, so I'm going to catch up tonight. And this has been going about since 2015. It's getting pretty popular this year. If you solve the puzzles within 10 minutes or so, actually that's quite a long time. Earlier days you had to do it within 5 minutes. You get points. I'm not that fast of a programmer. I'm doing this in Rust, so don't expect me to get any points in this competition, but I have been getting, on a really good day, under rank 1000, which I kind of like. I've been getting rank 2 to 3000 typically on okay days. So the themes are pretty corny. This year it's that we've dropped the keys to Santa's sleigh into the ocean. To save Christmas, we have to get in our submarine and go find them, and we're going through one adventure after another. So day 16 was about we've reached open waters after going through some caverns, and now we're receiving a transmission from the elves, and we had to decode it. So let's see what day 17 has in store for us. You finally decode the elves' message. Hi, the message says. You continue searching for the sleigh keys. Ahead of you is what appears to be a large ocean trench. Could the keys have fallen into it? You better send a probe to investigate. The probe launcher on your submarine can fire the probe with any integer velocity in the X, which is forward, and Y, upward, or downward if negative directions. For example, initial XY of 010 would fire the probe straight up, while velocity 10 minus 1 would fire the probe forward at a slight downward angle. The probe's XY position starts at 0, 0. Then it will follow some trajectory by moving in steps. On each step, the changes occur in the following order. The probe's X position increases by its X velocity, and so is the Y. Due to drag, the X velocity changes by 1 towards 0. Due to gravity, the probe's y velocity decreases by 1. For the probe to successfully make it into the trench, the probe must be on some trajectory that causes it to be within a target area after any step. The submarine computer has calculated this target area puzzle input. For example, target area 20 to 30, y minus 10 to minus 5. This target area means that you will need to find initial xy velocity values such that after any step, the probe's xy position is at least 20 and at most 30, and the y position is at least minus 10 and at most minus 5. Given this target area, one initial velocity that causes the probe to be within the area after any step is 7.2. Boink. Splash. Alright, I'm just speed reading this now. After initial velocity, another initial velocity causes it to be within is 6.3. Boink. Another is 9.0. One initial velocity that doesn't cause the probe to be within area of any step is 17 minus 4. So it basically goes through there. The probe appears to pass through the target area, but is never within it after any step. Instead, it continues down and to the right. Right. If you're going to fire a highly scientific probe out of a super cool probe launcher, you might as well do it with style. How high can you make the probe go while still reaching the target area? In the above example, using initial velocity of 6.9 is the best you can do, causing the probe to reach a maximum y of 45. Any higher initial y velocity causes the probe to overshoot the target area entirely. Is that true? Oh, I see, yeah. Find the initial velocity that causes the probe to reach the highest y position and still eventually be within the target area after each step. What is the highest y position it reaches on the trajectory? And our puzzle input is that. Do I even need... I'm not even going to bother to parse this, you know what? I'm going to just put that in a comment and then code it directly in the function. Save us some time, right? Why code it when we can just have it? So, there we go. That's the... that's the actual thing. So, to code that, we'll just say that it's const... target x, which is a range of I size equals 70 to 96. To do that, I have to call it a range inclusive, right? That's going to cause compiler errors. Oop. This is going to cause compiler errors until I do something about it. I think what I'll just do is delete the input. Range inclusive there. I have to call it a range inclusive, right? Yes. Well, actually, maybe not. Hold on. Import range. That's not what I wanted to import. Import range. No, it's the wrong type. Yeah, it's inclusive. All right. And then we'll say target y is minus 124 to 179. There we go. I've encoded the input. Done. Hey there, SureShock. And hey there, Prof. Elements 1. Okay. I have to admit, I don't really know how to solve this. So I got to think about it. Okay, there's drag. So 7, 6, 5, 4, 3, 2, 1. So one thing we could do is consider the x first and then the y. So we could find all the numbers that will get us from the position into the target area using numbers that drag. So there are only so many of those, right? Looks like physics projectile problem in high school. It does, doesn't it? I think I can separate out the x and the y and do this as separate problems, right? So I think I see how we could limit it. The target has a certain width, right? Here it's like 11. So if something was going too fast, it would miss it. So that kind of limits our how high our initial x velocity can be, right? But the math is escaping right now. Hey there, Maximum Homer Drive. How are you doing? Maybe I could just brute force this, but still split it between x and y. There might be some insight into when they're saying that 6.9 is the best that you can do. Any higher initial y causes the probe to overshoot the target area entirely. Why is that? They give the example for 6.9? No, they gave 7.2, and they gave 6.3, and they gave 9.0, and 17 minus 4 is a dud. But we can tell from 17 that it's going to overshoot, right? And 16 will also overshoot, I think, because it'll go here and then here on, if we just consider x, right? So there we go. That gives us the upper bound on the x at least. We know that 15 plus 14 is 19, but 15 plus 16 is 21, which is outside the bound. So I can start at the upper bound, divide by 2. So upper bound here was 20, right? Divide by 2 is, no, it was 30, right? 30. So divide by 2, 15. And 15 plus 14 is 19. Okay. And then I can just consider all of those ranges. So what's the smallest range? It would be where we reach this with one step left. So, okay, let me put these in comments. So, the highest x is upper, or target x and divide by 2, right? Lowest, let's call it Vx, is target x start projected back. I don't know how to say that, but like we would just add 1. We would work back on the velocity until we get to the submarine. And we might not hit the submarine. If we don't, then I take the next higher initial velocity. So say we're at 20 with the velocity of 1, then working, okay, let's plot this out. 20 with the velocity of 1, going backwards, we would be at 18 with the velocity of 2, and then minus 3, 15 with the velocity of 3, minus 4, minus 5, minus 6. We actually hit the submarine. So that's a velocity of 6, right? So that's the minimum x velocity. Unless we drop straight down like that, I guess. Hold on. Yeah, see, 2, 1. I guess I was off by 1. Oh, yeah. Velocity of 0, right? That's 20? 20. 1, 2, 3, 4, 5, 6, 1. Or 6, 5. 7, 8, 9, 10, 11. 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, right, 21. I was off by 1. This would be 19, 1, and 17, 2, and 14.3, and then 10.4, and then 5.5, and then -1.6. So if we take the lowest and work backwards, and then from here we just take the velocity, that's the lower bound on the velocity, right? So we have the x velocity has to be between 6 and, in this case, 10. Vx is 6 to 10, right? Now, don't I do the same thing with the y? But for each of these, right? Given a Vx, then the Vy has to be within some range too, right? Parabolic projectile program in code. Not exactly parabolic. There's x drag, but there's y gravity. That makes sense. So it's the dimensions are actually separate. The only thing you remember is you throw 45 degrees. So it's not true on this one. And I think it's because we're underwater. So there's an x drag, but then there's also the gravity. It's simplified. So, but this is the same problem, right? No, it's slightly different. We're going to accelerate one more every time. So at the y max, well, the y minimum really, because it's the smallest number. Interesting that they gave me a positive number for the upper range. Anyway, if we take the y coordinate at the minimum, and we're going for the highest, that means we want the number that we want to have a velocity of no more than like the range of these numbers. So, which in this case example, it was 6. So if it's here, then actually that's not true. It could be any velocity that ends up there. Oh, I know what to do. Given any velocity, we can compute the number of steps. The number of steps tells us what does that tell us? I don't know. I don't know if I'm going to get this one. The upper range isn't positive, you think? I think it was. Oh, you're right, it wasn't. Thank you. I didn't see that. So then I got this wrong. I would have failed horribly on the actual code. Thank you for correcting me. Okay, so it's always below us. Can I use that to my advantage here? I think I can, because if we know the number of steps that we would need, because we're going to consider for every possible Vx, we're going to consider the range of Vy. But really, we want the highest, the largest, highest V1, because that's what we want to get to the highest point, right? So let's say in this case it's 6 steps, right? 1, 2, 3, 4, 5, 6. So then I guess we could, the bottom would be like the furthest pitch down would be if we go here and divide by 6, right? So in this case, what was the example? Depth -10. So 10 down, and divided by 6 is 1. So it would be no more than -1, right? -1, 2, 3, 4, 5, 6. I should just plot this out. So if it was -1, then it would go -1, and then a velocity becomes -2, and then it's -3, velocity is -3, and then it's -6, velocity -4, and then it's -10, velocity -5. And we've already overshot it. So then that's the lower bound. So we would just increase it by 1. What do we get? -1, -2, -3, -3, 6, 4, 10, -5. But that's still only 5 steps, so we have to keep going. So 1, 0, 1, and then -1, 0, -1, -1, -2, -3, -3, -6, -4, -10, -5. 1, 2, 3, 4, 5, 6. So we would eliminate 6 steps, right? Am I doing this right? I feel like I should be writing code to do this and work it out. Maybe I'll do that. So I think what I want to do is I want these ranges to be the input. So this would be these would be range I sizes. So target X, target Y, and then target X, target Y. All right, and then let's just try to get this. So let me write a unit test. So the example they gave us is that it's 6, 9. If we give it the ranges of 20 to 30 and -10 to -5, right? I don't know what part 2 is going to have in store, so let me just delete that. You don't have to solve this problem because you'll suffocate in a few minutes, you think? Or you think the upper range? Yeah, you're right, Adrian. Okay, let me try to figure this out like iteratively. Have the program help me out here. So yeah, my idea was to compute like highest possible Vx. So let well, we can put it in a range, right? For x in well, for Vx IVx, initial velocity x, in, and then here's where we put the minimum, which is the start of the range, target X start, up to and including the highest, which is the n/2. All right. Is it begin? I can't remember. No field on it's private. Oh, I have to use parentheses? Why didn't you tell me how to use parentheses? Okay, obviously I don't remember how to use range, so I gotta look it up. Range inclusive. When using an inclusive range, the values that start and end are unspecified after the iteration ends. To determine whether it's empty, use is empty. Is this because range inclusive is special? I thought with range I could just call start and end. Okay, maybe I shouldn't be using range inclusive. Because these are methods now, right? I guess I can, it's just that they're iterators, so I have to dereference them. Okay, that's all I needed to do. Weird that they have this thing about it being iteration. It says this is an iterator. So I guess it's when we start calling next on it, it can change it. Hey there, A squared. Range is a stateful iterator. It's just, it threw me for a loop that range has fields and range inclusive does not. Right? Range has fields, but range inclusive has methods, or it has these fields, but they're private. Anyway, that was all to get that. So the idea was what? To start at that velocity and the starting, no, to start at the end and work our way back. So we would pick, what was I picking? The right extreme? No, the left. I forget what I was picking. I need to look back at the instructions. All the range types except dot open, that's like range open beginning, right? Are iterators. They don't implement into iterator like you might think. I understand. But the fact that one had fields and the other one didn't, or one's fields were public and the others weren't, threw me. Okay, right. I already took into consideration the highest velocity is the end over 2 because... Oh, wait a minute. Is that right? No, it's not end over 2. It's end minus... It's the difference between the end and the start. That's what it is. So it's like end minus start. Right? Because any more and will go right through it, I think. Actually, that's not even true. We could land directly on it. Oh no, I was thinking about this right here, where if the velocity was more than, like, yeah, okay, it is end over half, because if it ends up being more than that, we can never start at the submarine, and we'll just bypass it completely. Actually, that's not true. We could go straight from there in one step. So really, I should consider going. The maximum of the starting velocity is to go from the submarine all the way to the end. Okay, all the way to the end then. That's easy. And for each of those, I guess we'll just plot all the x's worked out from the submarine to the target. So let mut x equals 0. Let mut vx equal ivx. Why did I say vs? Because my hand wasn't on the keyboard correctly. Okay, I have 26 minutes for the next day 18 starts. While x is less than target, well, while target x contains x is not true. It's me hitting the wrong keys again. Keeping the magic smoke inside the computer? Oh, wait a second, I missed something. That was a promising new test. First test of the PC. Power button worked, no smoke, all the fans started. Tomorrow, to stick a monitor on it and load up Windows. How do you know the power button worked? Oh, the fan started? Some computers, I don't think they would even start unless you had a monitor hooked up. I've heard about that, where they refuse to turn on if you don't have a monitor connected. Anyway, we would just say x plus equals vx, vx minus equal 1, and we'll just plot, I guess, print line X equals something, Vx equals something. X, Vx. Let's just print that out for now. And we'll put like something at the very beginning here, like print line, a bunch of dashes. Print line, initial Vx equals... Actually, we'll see the initial Vx. No, we won't. I need to print it. There we go. Let me just see what I get. Can't compile because I expect... Okay, I need to borrow. Right here. Run that again. All right, so here are all our possibilities, and it broke. What did I do wrong? Why did it stop after just one step? Oh, wait. It starts at 20's wrong. I have that wrong. Oh, shoot. That's wrong. Really, it's we don't know what it is. I guess it's 1. Oh, we have to stop if x gets to 0. So while that and x is greater than 0, that means we could just start at 1, right? And then maybe we'll get some insight on where we could actually start. That didn't work. What am I doing wrong here? Oh, Vx. Yeah. Okay. There we go. So we start to see where we get some numbers. Like, there it's not even getting into the target, right? Here's for the first one, at 6 it gets to the target. So is there something about this that we can skip 0 to 5? Or maybe I can just keep that logic in there? Maybe. I mean, it runs pretty quick, right? And the real input's not that many numbers. Yeah, we're not gonna go through very many x's, so I think I'll just keep this. I closed the terminal. I was stupid. I wasn't done looking at it. Look at it again. So it's 20 to 30 is our target, right? 20 to 30 is our x target, and we don't even get there if we don't go 6 or higher. 6 or higher, we hit it. Oh, this bypasses it. We should have it stop. And to help me out, I should actually have it print something. I'm going to modify this a little bit. What I'm going to say is I'll say while x is less than the target x start, right? And then we'll say if it contains it, otherwise, so if it contains it, hit the target. We'll just say hit. Can't type. Otherwise it's miss. All right, try again. Okay, there we go. So miss, 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 miss. 6 is a hit, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. No, these are not hits. No, these are hits. They're hitting in one step, though. Right. Okay, so they all hit but they hit it in one step. I wonder if we could just discount that. We can, right? We can automatically discount that. So we can just go until it misses, looks like. And then stop. Or I can just keep it the way it is. It's simple enough. So we can say that if it hits in an X, we can try all the Y's, and we know how many steps there are, right? So let's say hit in blank steps. So let mute steps equals 0. Steps plus equal 1. Let me make sure I got the steps correct. Yeah, so hit in 5 steps, right? 1, 2, 3, 4, 5, right? 4 steps, 3, 3, 3, 3, 3, 2, 2, 2, and then these miss, and then we start hitting in 1 step. I guess we should include them. It's okay. So if on all these ones where we hit, we'll take the number of steps and we'll see how, I guess we'll just try all the Y ranges again. So then what, I need to get some insight on what range of Y to try here. Why don't I just try them all and see if I learn something from the output of the program. So then it would be for IVY in, I don't know, what's the lowest we should shoot for? Probably the where we would hit it in 1. So the target Y end to, and then go to I don't know, until we miss. Well, given a number of steps, every step is 1 minus that, so I'm just thinking, like, if we knew it was like 10 steps, then if we aimed so high that we would never slow down, it's impossible to slow down and hit 0 again, what would that be? I don't know, let's go to 100 and see what... I was never very good with math, so let's just figure it out. So then it's the same kind of thing, kind of. Actually, let's just repeat this all inside here. But we'll do equal signs. And this is a Y. These are all Y's. Let me rename this one to X steps. Actually, that's not, we don't need to count steps. We know exactly how many steps are. Yeah, so it's a little bit different. It's for blank in 0 to step, or 1 to steps. Or 0 to steps non-inclusively. And then this is a little bit different, right? Actually, no, it's the same. The drag is in the same direction, sort of. And I don't need to do that. I would just do Y here. And then if it contains it, then we hit it. Hit Y. Miss Y. All right, I just want to print this out and see. Maybe 100 is way too big. I mean, it's not a whole lot. Then I can search for hit Y. We never hit Y. Why not? Did I goofed up? Oh, we're printing way too much. Shoot. Let's try a lower number. Like, yeah, I need to know what this number is going to be. How about 10 for now? Whoops. I got 15 minutes before I got to start on the next day. Is this too much output? It sort of is. Because this is at x14. Yeah, no, we never hit Y. Maybe get rid of some of my debugging. How about we get rid of the, I could say the coordinate we hit it at. And then get rid of this inner loop printing. That would help. Okay, good. And so hit Y. Never hit Y. Why not? We should hit Y for IVX6. Okay, it must have a bug. Let's print out what it is. Because I can look at the one where we know it should hit, and I can see what my problem is. IVX6, right? Oh, I need to print out both numbers. Duh. Ivy. I'll figure this out eventually. Are these glasses new? No, these glasses are old. But I've been slouching, so that my camera needs to be... Either I need to lower my camera or not slouch. The lighting's always different, you know, day to day. IVX6. Wait, that's not right. It shouldn't shoot up like that, right? This one hits it at, okay, so at 6.3. It says we miss it at 5. That's not true. Something obviously wrong in this logic here. Y plus equal Vy. Vy minus equal 1. Do that in x, some number of steps. Why is it at 5? It should be at, you know, negative something. 1, 2, 3, 1, 2, 3, 4, 5, 6, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, 5, 6, 7, 8, 9. Yeah, this is wrong. Direction of Y? Direction, well, Y starts at 0, right? These are all signed, so it decreases by 1 every time. So if it starts at 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I think I see the problem. We didn't continue. Yeah, there could be more steps. So okay. I didn't consider that the x, we have to consider, we have to go beyond the number of steps. Because we could lose all our horizontal velocity and fall into the destination. So I need to like change this loop. There's two conditions, right? Let mute or step equals 0. So we can say while step is less than steps, or x, well, no, or y is greater than target y end. Step plus equal 1. Okay, that's probably what it was, right? So 6, where's 6? Way up here. Oh, we didn't detect hitting. It says it missed. Yeah, shoot. I have to put this inside the loop. Right there. Break. And get rid of this. Why do I have this thing in here? Oh, because I copied it from there. This, that, and the other thing. Well, I guess we'll just check it again. I have 8.5 minutes before I gotta move on to the next day. Aha. Okay. Oh, no. We have to go the... Okay. It has to be an and. This... We have to go at least a number of steps. So if that and... Yeah. We have to at least go the number of steps, but then we can continue going if we want to fall into the target. Okay, there we go. So the highest we can go is 6.9, like they said, right? Okay, so this will do it, right? So I just have to find the highest IVY that hits for every... Yeah. So we hit with 7.9 also. Interesting. This isn't right, is it? I think I got a bug. It shouldn't hit, actually, in 2 steps. No, that's not right. The falling only works if the number of steps, if Vx is 0 after that number of steps, right? Maybe it was a mistake to separate x and y like that. Like here we can't continue going because we'll fall outside. Here we can because we stopped on it. We're not going to test below the under limit, right? Oh no, we are. How did I figure it out? Oh right, if we stop, we're not on target. So I think we need to know if we stopped, if our velocity was 0 when we got to the target, right? 1, 2, 3, 4, 5. No, I have to simulate x at the same time. That's what we have to simulate x at the same time. Shoot. Yeah, shoot. So take this again. And then do this again. And then we have to check that both targets hit. Actually, then I don't even need to check that. If target X dot contains X and Y contains Y, then we hit it. There we go. I think that'll work. Let's try it out. We're iteratively approaching a solution. I got 4.5 minutes. Could not compile. Because why? I don't even see my error. Oh, there it is. I don't have a comma and then a position for the Y. There we go. Let's go! Woo! Direction of Y is an old comment. Never mind. Okay, so let's test here. That's not right. Did I get it backwards? Oh, maybe that was right. 20 to 30. But then we missed on 9, though. Oh, did we stop too soon? One more bug, at least. I think I need to get rid of that. Yeah, let's get rid of that. Just continue until we fall past the Y. Because we eventually will. No, this is still wrong. What am I doing wrong here where it doesn't, where 6-9 doesn't work? I actually never use step then. While we're above the end, actually it should be while we're above the start. Yeah, we should do that, right? The lowest point, above the lowest point. We advance, and if we're in the target area, we hit it. Break out. Oh, this should be the opposite of this. That's probably where I got it. Well, no, we should at least print it out. At I'll get this eventually. Probably after I do today's one, I'll come back and do this one. It's like we're not even trying. What am I not printing? Oh, it should be not. Duh. I at least wanted to print something for 6-9. See, what am I doing for 6-9 that's wrong? Okay. It went negative. Okay, so I have something wrong in the X. Oh, right. It can't go negative. That's the problem. So this should be Vx equals 0 maximum Vx minus 1. That's important. There we go. Yeah, so we hit all the way up to, so that's the highest initial Y velocity that will allow us to hit it. And again, at 7-9 and then 8-9 misses, right? So we could actually do 7-9 and still hit it at 28 and -10 in 4 steps, I think. Okay, but anyway, I gotta stop day 17 because guess what? Day 18 is starting in 15 seconds. We're out of time. We'll come back to day 17. But let's pretend like we finished day 17 and start on day 18. Get ready, let's go! Snailfish. You descend into the ocean trench and encounter some snailfish. They say they saw the sleigh keys. They'll even tell you which direction the keys went if you help one of the smaller snailfish with his math homework. Snailfish numbers aren't like regular numbers. Instead, every snailfish number is in a pair. An ordered list of 2 elements. Each element of the pair can be either a regular number or another pair. Pairs are written as XY. XY are the elements within the pair. Here are some examples of snailfish numbers. 1 per line. All right. Example. So, trash. Go to day 18. Paste the snail numbers. Snailfish homework is about addition. To add 2 snailfish numbers, form a pair from the left and right members of the addition operator. For example, 1, 2 plus 3, 4, 5 becomes 1, 2. Oh, I see. There's only one problem. Snailfish numbers must always be reduced, and the process of adding 2 snailfish numbers can result in smaller numbers that need to be reduced. To reduce it, you must repeatedly do the first action in this list that applies to the snailfish number. If any pair is nested inside 4 pairs, the leftmost such pair explodes. If any regular number is 10 or greater, the leftmost such regular number splits. Okay, they'll probably define what those things mean. Once no action in the above list applies, the snailfish number is reduced. During reduction, at most 1 action applies, after which the process returns to the top of the list of actions. For example, if split produces a pair that meets the explode criteria, that pair explodes before other splits occur. Huh? To explode a pair, the pair's left value is added to the first regular number to the left of the exploding pair, if any. And the pair's right value is added to the first regular number to the right of the exploding pair, if any. I think I need to see some examples of this. Exploding pairs always consist of 2 regular numbers. Then the entire exploding pair is replaced with the number 0. Okay, let's see what this is. Here are some examples. So this is deep. This is 4 deep, right? The 9 has no regular number to its left, so it is not added to any regular number. So what, the 8 goes into the 9 above it? Then the 8 goes into the 1 and becomes a 9? Right? And then 2, 3, 4 is the outer structure. Okay. I think I see that. So the 3 gets added to the 4. The 2 has nothing, so it doesn't go anywhere. So I see. The 3 got added to the 4. The 2 didn't go anywhere, and the whole thing became a 0. Right? So you always get a 0. Right, so that becomes a 7. Oh, it goes all the way back up and out? Okay. So that becomes an 8, and that 3 hits the 9. Got it. The pair 3, 2 is unaffected because 7, 3 is further to the left. Oh, I see. So we only explode 1 and then we start over? Is that what it said? The leftmost such pair explodes. Got it. At most 1 action applies, after which the process returns to the top of the list of actions. So, okay, the list of actions. So we try to explode, and if we can't explode, then we split. Got it. This one is it is complicated, isn't it? So this. So how deep are we here? Where did it say 4 again? Nested inside 4 pairs. Okay. That means if we're at level 5, right? So 1, 2, 3, 4. No. That's inside 1, 2, 3. How come that explodes? Oh no, that's because, sorry. This one is inside 1, 2, 3, 4, explosion. 1, 2, 3, 4, 5. Right. So 1, 2, 3, 4, 3, 2, 1, 2, 3, 4, 5, explosion. Got that? All right. To split a regular number, replace it with a pair. The left element of the pair should be the regular number divided by 2 and rounded down. Well, it's divided by 2 and rounded up. So yeah, 10 becomes 5, 5, 11 becomes 5, 6, 12. Okay, got it. 1, 2, 3, 4. Okay, there's an explosion. Oh, sorry. So the addition just nests this one and this one inside of another pair. Then we have an explosion. So, right. Nothing to the left of the 4, 3, so there's a 0 there. Well, there's always a 0 there. No, the 4, 3 becomes a 0. The 4 doesn't go anywhere, but the 3 gets added to the 4 to make a 7. Right, and then 1, 2, 3, 4, 3, 2, 3, 4, 5. So we find another explosion. That 8 moves out to the 7 to form a 15. That 4 moves out to the 9 to form a 13. And the original pair became a 0. Okay, so what I get from this is that when we detect an explosion at level 5, we replace the exploding pair with a 0 immediately, and then we take the two numbers and depending on if it was to the left or the right of the pair, either we take in this case it was on the left of this pair, we take its right one and immediately add it to the right one on one up, right? But then we have to, for the left, we have to keep going up until we come out on the right hand side of a pair, and then we add it there. And if we don't find anything, we just toss it. Okay, I think I got that part. So there's no explosion at this level, right? So we split. So the 15 becomes a 7, 8. And then we split the 13, and then that explodes because it's too deep. So the 6 gets added to the 0 to form that 6. The 7 gets added to that 1 to become an 8, and the original becomes a 0. I got it. All right. I think I understand it. Once no reduce actions apply, the snailfish number that remains is the actual result of the addition operation. So I kind of want to use this example as a test, not the original numbers they gave me. Yeah, I think that was the wrong thing. I think I want this to be the unit test. Oh, they gave me more examples, so I should just keep reading. So the homework assignment is adding up a list of numbers. The numbers are each listed on a separate line. Add the first to the second, then add that result to the third, and then add that result to the fourth. Oh, okay, so just chain them. For example, the final sum of this list is, oh, I see. These are our inputs. Okay, I can do this one. Let's start with this one. Because then they're giving us multiple examples. Right? To make our life a little bit easier. So this one's actually just adding that 5, but that's fast enough. Hold on. Copy this. Copy that. Paste there. And then we'll slightly longer example will. So this is nice of them, really. Give us some simple ones that have no explosion rules, and then here we have one with an explosion, right? And then even give us the intermediate steps. So if we don't pass this last one, then we can break it down and look at the intermediate steps. But I'm pretty confident. I'm confident we'll do this. What do you guys think? What do you think? Will I pull this off? This will be what we compare to our prints when we don't get it right. Check whether it's the right answer the snailfish teacher only checks the magnitude of the final sum. The magnitude of a pair is 3 times. Okay, so you know what I'm going to do is first verify that the tests are correct and then modify it to add this final rule in there, because I'd rather see it like that form first, not the final form. We don't want to see the final form yet. All right, so then we're going to do this with reduce, right? Yeah, might as well. Input.lines.map line to line.trim. Gotta think now. How do we parse these? So I think what I got to do is make a scanner that counts the number of counts the level that we're at, and when we get to 0, we would stop. So we can what we can do is we can toss the outer brackets, move it in 1, and then count from the left until we get to 0, and then we would expect a comma, and then the rest is the other pair, and then just do that recursively, right? Let me define my data structure. Struct. Before I do this, before I forget, let me get my puzzle input. Paste it into 18.text. Close that up so I don't have to worry about our input now. There's one year where like there was a lag to get my input and it cost me. Okay, data structure. Snailfish number. Enum snailfish number type. Well, kind. I don't like to use the word type because that overloads the term type. So 1 is just a number, scalar. Are they all whole, like non-negative numbers? Looks like it. In fact, they're digits. Well, yeah, ultimately we add them, right? And we split them, but we never go negative, so we can just keep it as U size. And then pair snailfish number, right? And we're gonna have a problem with recursive structure unless I do a box snailfish number, because this is really just oh, what am I thinking? I can just make this one thing. I don't need that. Yeah, this just becomes a pair of them. There we go. Yeah, you have to introduce a box there. If you don't, interesting things happen. Basically, the type has an infinite size at that point, and it'll tell you this. Has infinite size. So you do, in fact, it tells you there in the compiler error. It'll say, consider using a box, a reference count, a borrow. We're going to use box. What happened to my undo stack got trashed. Box is basically a hold on, I can't think and type at the same time. Box is basically a pointer onto the heap, an owned pointer. So it can be null. I mean, it can't be null. It's that its size is just the size of a pointer. So without that box level, then it's impossible for the compiler to know which of these two the alternative is going to be, so it has to assume the maximum of both, and then it gets into an infinite recursion when it's trying to calculate the size of this. But if you use box, the size of a box is just the size of a pointer, no matter what the size of the thing pointed to is. So this just ends up being this is the size of usize, and this is the size of 2 pointers. So that's why it works. So I guess I might as well just implement from string for snailfish number. Import that. Missing members. We don't produce errors. We do, we're always okay. If we're not okay, we're gonna crash. Here's where it's gonna get a little funny though. I have to remove the left and right characters. So let s equal s1 to slen minus 2, right? So if like the length is 3, we want to go from 1 to 2. Yeah, length minus 1, right? Yeah, because this is a non-inclusive range. And I have to say like to do, otherwise it's gonna complain, right? Yeah, I know it's unreachable. Don't worry about it. And then yeah, map snail fish number from string. Let's just say let x equal that, so I can get my types I want to collect into a vector, just so I can see the types, make sure I get this correct. Okay, yeah, I don't want to do a result. I want to unwrap them, so map. Actually, can't we just do option unwrap? Maybe not. No, it's not option, it's result. Yeah, vector snailfish numbers, that's what I wanted to see. Okay, so then after we pry off the left and right brackets, we want to scan from left to right until we get to 0. So we need to have an incrementing counter. Let mute level equals 0. And then actually, then I could just start, I can do that. Do I even need that? I don't even think I need that. I don't need that. Screw that. I can just do a loop here. Match S. I don't even need a loop. I can just say for C and S chars. Match C. If it's a left bracket, level plus equal 1. If it's a right bracket, then we might break early. Level minus equal 1. If level equals 0, break. And I want to know the position, so let's do chars. Let's do position and character and chars enumerate. Break position and then let position equal that. Okay, and if it's anything else, let's do nothing. This is just to find the break position. What's wrong with this? Cannot be dereferenced. Oh, right, it's not a reference. Can I? Okay, I can do that, right? Why can't I break out of a for loop? Can only break with a value inside for with a breakable block. He's breaking on someone with a value, but I want to break. I guess I can make this into a while loop. While let position char C equal S chars enumerate next. And then let the position equal that. Sum. There we go. You can't break from a while loop? Shoot. Oh, Russ, why do you torture me so? I need... Do I want to do a find then? I think I want to do a find. Yeah, let's turn this around and do a find. So enumerate find position and care. Wow. The inlay hints are killing me. Just hit enter. End that. Begin that. Yeah, and this just becomes return. This needs to be a find map, actually. Some position. Actually, find by its own. What does find by its own return? Find for an iterator. What does that return? It returns the item. Yeah, we don't want the item. I want to map it. So I want to return the position. And if we get all the way out, it's a none. So that's what I want, right? Say what? Oh, shoot. I need to, if I get out of this match, I want to, do a none. Like that. Okay. And then we want to unwrap that, basically to say crash if we don't find it. So, let me walk through this. For a simple on, like, bracket, we'd be at level 1. And then we get a number, so we wouldn't advance. And then we get a comma, we advance. Then we see the right bracket. So it's that position is the position of the terminating bracket, right? So it would probably be better to add 1 to it. And then we would say let left-hand side equal s from 1 to position. Let right-hand side equal s position plus 1 to s.len minus 1. And then, should I just verify this works? We would return... Well, no, at this point I need to know if it's a scalar or a pair. We know it's a pair if either one of these is a bracket, so that's easy to test. Match left-hand side chars next unwrap. If it's, well, if let some open bracket equal left-hand side chars next. Then we have ourselves a snailfish number pair, box new, snailfish number from string left-hand side, and box new snailfish number from right-hand side. Right? By the way, if scalar... Oh, wait. We could have a scalar in one position, but not the other. So I have to be careful about this. Yeah, I have to be really careful about this. This is wrong anyway. I know what I need to do. If the first character is not that, it's a scalar. So we have to exit right away. If s chars next, if let Or if matches, really. Some C if C is left bracket. If it doesn't match that, then we have a snailfish number scalar S into, or S parse unwrap. Return that. There we go. What's wrong with this? Delimiter not closed. Oh yeah, because I didn't finish this. Right. So then I don't need to do that. Really, it's always going to be this. Like that, right? Whoops, what is it not like about? Oh, this needs to be actually a tuple. Tuple, whatever. What's wrong with this? Remove the parentheses. Why? Okay, I'm missing some syntax here. What's wrong with this one? Mismatched types. Oh, we need to have a return okay. So we can put that outside, actually. But what's wrong with... where's my mismatched syntax here? That should go like that, and then overall that, right? So then what's wrong with this? Oh, mismatched parentheses. And one more here. And I have to unwrap these. There we go. So I should probably test that, right? Before I go any further, let's test that. Test function parse snailfish numbers. Assert equal snailfish number scalar 42 if we pass it the string 42, right? That's easy enough. But if we, let's try a pair of two scalars. Pair of scalars. 1 and 3, let's say. Box new for 1 and 3. Oh, forgot. Are we gonna handle spaces? Does the input have spaces in it? Nope, no spaces. I don't have to worry about spaces. Good. All right. So to make this possible, I have to derive partial equal. Derive partial. Actually, will it let me do that for boxed things? Maybe. I don't remember. Oh, also debug. What now? Oh yeah, this has to be parse, I think, right? Unwrap. Spell that correctly, and then this goes there. Enum takes one argument. All right, it's a tuple. Tuple of boxes. Okay. Now let's do a slightly more complicated one. Let's have like a left-hand inner pair. 1, 2. So that's like taking this and nesting it inside itself. Right? And box the left-hand side. All right, and then we'll do the same thing for like 1, 2, 3, like that. I gotta remove the spaces. Okay, so then that's just kind of flipping these two around. I'm putting the scalar there and the pair there. All right, let's see if I got it. And I panicked. Byte 6 is out of bounds, and 0, 1, 2, 3, 4. It is out of bounds. So on line 36, we got out of bounds. 38, actually, right here. Really? Let's print that. Position, well, comma, for there is at there. S position. Let's see it. So now I'm glad that I'm making sure the parsing is correct first. Comma for that is at 5. 0, 1, 2, 3. That's not correct. Why would it be at 5? So we start at 0. Level starts at 0. The first character is that, so level goes to 1. 1. Oh, shoot. We don't want to start at the first character. We want to start... Yeah, we want to skip 1. So chars dot enumerate dot skip 1. Yeah, otherwise it won't be until we get out of it. So let's try again. Line 37, panic. Okay, what does that mean? Let me think about that. We skipped 1. Oh, I'm not supposed to look for the match. I'm supposed to look for the... Oh, alright. This is wrong. We always just subtract 1 from the level. It's when we get a comma, do we say, if the level's 0, that we return that. Yeah. I knew the comma needed to be significant. I just didn't remember why. Okay, run, not that, this one. 0, 1, 2, okay, we're off by 1. Yeah, I don't want to add 1. So don't add 1. Don't add 1. There we go. This is why we have tests. And make sure we can parse our snailfish numbers. Zero, 1, 2, 0, 1, 2, 3, 4, 5, 6. See, that's correct. What is it breaking on? I probably got the left-hand side and the right-hand side wrong. Let's print those out. Left-hand side equals some string. Right-hand side equals some other string. Hey there, GTX Gaming. This is Rust. Can you recommend a good C# book for medium programmers? It's been many years since I've read a C# book, so unfortunately I can't. I'm sorry. Maybe someone else in chat can. I got an email today saying that C# 10 was out, and I'm like, man, it's been a while. I think the last time I programmed C#, it was version 5? 6? It's been a while. Left-hand side is 1, right-hand side is 3. Well, that looks correct. What am I getting wrong then? Maybe it's this that it's having trouble with. Oh, this is wrong. That's bad. There, I fixed it. My test input was bad. It was supposed to break. Okay, so cool. Cool. We can parse it. The advantage of this being Rust is that this derive of debug gets me exactly what I want, except with the... Actually, no, because we actually have the double quotes. But I can fix this. The display trait won't be too bad. Let's do it. Implement display for snailfish. Because I'm going to want to convert it back to a string. use standard format display. It's one of those things that doesn't auto fill in for me. And then let's make some other tests here. I guess I can just take it and turn it around. So like assert well, why can't I just parse it and then parse it back? No, I know what to do. Just remove that part and then put toString there. Yeah, exactly. toString. toString. That, and then one more. toString. So we can go to and from strings, because that's going to be critical in the next part, right? Not implemented yet. Let's implement it. So it basically is match on self if it's a scalar or not. If it's a scalar, it's just, we're going to print that out. Oh, thank you for the follow. I was like, saw a flicker in the on the monitor next to me, and I'm like, what was that? It was a follow notification. Okay, right. It's this way, right? Right. The formatter comma. Or actually, because we know the n can be formatted, we can just do format f, right? Yeah, I can just do it that way. For this, though, we can take advantage of the write macro. Write into the formatter, bracket, something, comma, something, and then the somethings are the things in the pair. So left-hand side, right-hand side. Yeah, it's way off the screen because of the inlay hints, but trust me, it works. Run the test. Cool. So I can get rid of the comma for this print thing. We don't need it anymore. Now we can trust that it works. It's nice and recursive, and it goes in both directions. Okay. Now that the parsing's out of the way, we can trust that we get our snailfish numbers. And then what I want to do with those numbers is reduce them, right? So instead of collecting them, we want to reduce them. And the function takes, I believe, two operators, right? So the accumulator and then the next as small fish numbers, and it's got to add them. And at the end, we want to, for now, we're just going to convert it to a string. What we're going to do, let's just make sure this compiles. I'll just put the accumulator in there. So just show me the left-hand number, right? And then option, because it might be empty. So we'll always unwrap it. Okay, so let me test this. We should get the first number always instead of the actual answer. Just to make sure that I got that logic correct. Yeah, so we got the first number out. So now to actually implement the reduction, that's all in this little function here. So they told us to start with forming a larger snail number. So let's do that as a step right now. We would say it's snailfish number pair box new accumulator and box new next. So let's see what that looks like. It's not going to pass, but it should show me the number before is collapsed. Oh, interesting. Yeah, so these don't actually have any explosions or reductions, right? This one What's the first one that should... Okay, this one, I guess. Yeah, this one has an explosion in there, right? Or two. Okay, so that's good. This one already passed. This one failed because we didn't do an explosion. Now for the hard part. We have to walk. I think this is a data structure walking problem, right? Yeah, because 1, 2, 3, 4, 5. This 1, 1 should turn into a 0, and this should turn into a 3. Why does there a why is that? Why is a 3 end up on the left there though? Did I fold these correctly? Is to that take that, add 2 2? Yeah, I think that's right. 2 3 4. 1 2 3 4 5. So that becomes a 0, and that's a 3 2. Hold on, let's do this on paper, or on simulated paper. Doesn't that just become... That becomes a 0 and 3? 1 2 3 4. Oh, but then that explodes. So that puts the 3 back into there. This becomes a 0, and then that 2 goes out to here to a 5. Ah, so this is 2 explosions. Boom, boom. So I think we're just going to descend in order. Left, right, down, left, right, until we get to a level 5, and then we ought to stop. And okay, I think I got it. So when we're descending the data structure and we find this, let's take this as an example, this 3 2, right? Then we'll return to the caller the fact that it exploded. And so the caller, which will be looking at this pair, says, okay, there's an explosion on my right-hand side. So that means I need to take what was the left-hand element. I guess we'll return that. We'll return the left and the right, right? We'll say explode returns the 3 and the 2 out. It would take the 3 and add it directly to the 0 that it had, and then I guess we'd have to return back out that that nothing gets emitted to the left, but a 2 needs to go to the right, and then the caller of that would be here, and it would say, okay, well, I need to distribute a 2 to the right, so it would call another function to say distribute, which would descend to the leftmost, along the leftmost path, which would be this 3, and then add it to... So there's 2 operations here. There's the explode, whereas the detect explosion, and then there's the distribute, right? Can they be the same as we're walking it? No, because if, like, when we take this 3, let's say this was actually a group here, that 3 would have to go and then descend into the left-hand side. So there needs to be like a distribute left and a distribute right, and a detect explosions. So let's do this. We would take this pair, let mutable number equal that, and then we would have to do like number dot well, they want us to do the 2 rules until there's no rules, right? So I guess we just do a loop. And we'll just return the number at the end. And the first one would be like, if number dot explodes. If let something we don't care about, then continue. And then the other one would be split. If let some equal number dot splits. Let's call explode. Let's make it singular. Otherwise, we're going to break, right? So this kind of a loop says try to explode. If you do, try to so keep trying to explode, but if you can't explode, try to split. And if you can split, try to explode again. And if you can't explode or split, break out. So we just need to define what explode and split means. Easy enough, right? Implement snailfish number. Your Go solution was not... was very not... very not safe. Hey there, Aneurysm. How are you doing? Honestly, a little afraid of when it comes time to do this one in Rust. Well, the tricky thing in Rust is to know that this structure is infinite size unless you have a level of indirection. That's just something you have to know. Explode, right? Mutable reference to self and returns two numbers, really. An optional two numbers of what to distribute left and right, right? We'll implement that later. And split, I think to just return a Boolean, right? That just tells us if there was a split. So this could just be if split. Continue. All right. Do you recommend learning Rust to a backend engineer? Totally. Rust has got a lot of advantages for compiled environments like what you'd have in the backend. Front end is where it gets trickier because you can host a Rust in a WebAssembly front end where it does just-in-time or client-side compiling or interpreting, but you have to introduce extra layer of WebAssembly and all that junk. Backend, though, it's a perfect place. Anywhere where C and C++ would go, and Go itself, I think, as well. I don't know Go, but Rust is suitable for that, even embedded stuff. So Rust is even going into the Linux kernel, believe it or not. One way I like to think of it is Rust is really just the same technology that's in C and C++ and Objective-C. Anything that's based off of LLVM or GCC, the compiler tech, but just with some extra levels of type checking on top, really. That's what it really comes down to. All the stuff that we're doing is just adding extra layers of types. So option type, the enum types. Because it ultimately gets compiled down the same way C++ do by the same compiler backend tech, like LLDB or GCC. All right, explode is a hard one. Let's do the split first. So the split is easy. We just would... Oh, hold on. We want to change something into something else, so the easiest way would be to own it and then to return it back out, I think. Yeah. This is going to look gross. So, like, self and a bool. And then to call it would be kind of weird. Let did split. Can I... I can't make a new symbol. Well, this is going to look ugly. Something like this, right? Number did split equal did number dot split. If did split. Continue. It won't even let me do that because it's unstable. Okay, forget that. Probably problem is if I make it mute self, it can't change itself from a scalar to a pair really easily. But that's what we have to be prepared to do, right? Unless we say, like, we try to split our left and our right. No, I don't like that idea. I want this to return something new, but how do we know if it actually did something or not? I guess we can just do it this way. We can have another, we can just keep it like that. Actually, I can do it this way. Let did split, well, new number did split equal number split. Number equals new number. If did split continue, that'll work. So since we own the number, we're allowed to move it into the split and then move it back out, right? It's a little trick you can do with Rust. So split owns it, that means split can change it. So it makes it kind of easy, right? We can do a match on self and say if it's a number and if n is greater than 9, otherwise it's just self false. And if we split, then it becomes something a little bit complicated, right? It becomes a pair with two scalars in it. And a true. And the things that are inside are where we have to split it down the middle, right? So it's n divided by 2, and then n divided by 2 plus 1. No, not plus 1. N plus 1 divided by 2. Right? That's how we round up if it's uneven, but keep it the same if it's not. And then we have to box those two. Okay, so there's where we actually split. Here's where we didn't need to split because it's not greater than 9. And then a pair, we need to do it recursively on the two things. So that's left-hand side, right-hand side. We would just turn it around and make it a pair again. Actually, we have to, this is a little bit more complicated because we have to see which one splits first. So actually it's the same as the outer thing here, right? This thing. Let new left-hand side equals did split. Left-hand side equals new left-hand side. So make that mutable. Do I even need to do that? I can just say let. In fact, I can just say that. And then this is left-hand side split. If did split, then actually we're supposed to stop after one split, right? So it's just left-hand side and right-hand side. And that's a return true. If it didn't, then we try the right-hand side. Let right-hand side equal did split the right-hand side. If it did, then we return true again. Otherwise, we just return... how come it's not letting me do that? I think it's because of this error. I think I can, this is going to be a little bit repetitive, but I think I will be able to reduce it in a second, because this just becomes false. I just need to fix my syntax errors here. Okay, what's wrong? No comma. Okay, now what's wrong with my right-hand side here? Expected snailfish number found struct boxed. Snailfish number. Why is it expecting an enum here? It should be expecting a box. So what did I do wrong here? Oh, right-hand side is a box. Okay, so I don't need to box it. It's already in a box. And then probably this left-hand side. No, we unboxed the left-hand side when we tried to split. So we have to box it again. Okay, so then this is correct, right? This is the split. Result? Why result? Oh, you're answering a question. Would you... No, you're not answering a question. What? Hey, A squared, what question are you answering? Not using result. Oh, you're saying instead of this tuple, use a result? But is that a common pattern? I haven't really seen that a whole lot. And isn't it just kind of stretching the meaning of result? Because it's not really an error. It's just, in this case, it didn't split. So, yeah, I think I'm going to use my unconventional way, if that's okay with you. So explode, right? I think explode needs to know what level it's at. So let's introduce that. Well, actually, all I need to do is add a level here. Level use size, right? And then we'll get an error where we used it down here. And here we'll say explode, we're at level 0, right? Here's where I might be off by 1 in a minute. Like those either types in those cases, well then make your own status type names, but a similar pattern can make things better if you want. Well, you don't like tuple? You don't like tuple? You're probably right, A squared. Let's see how far tuple gets me. So for explode, it's very different logic if we're at level 4 or not, right? If we're at level 4, then we explode if it's not a scalar. We explode immediately, right? So if level is greater than 4, 3, 0, let me make sure I count this right. 0, 1, 2, 3, 4. Explode. Thank you for the follow. Yeah, so if it's greater than 3. If it's greater than 3, then we explode. And we'll never have it be greater than 4 because we will have already exploded before that point, right? Unless they give us input that is deeper than 4, which I should double check. Did they give us any input that's already explosive? Yes. That's already explosive, isn't it? No, it's not, right? That's almost explosive. That's going to explode immediately after, but it's not already deeper than, okay. 0, 1, 2, 3, level 3. Okay, yeah. That's almost explosive, but not quite. Did they say in the rules that they give us numbers that are stable to begin with? I'm going to trust that they did. So that means that level can never be greater than 4. So if it's 3, that means the two things on the left and right must be scalars. So we do a, well, it has to be a pair, right? No, it's if it's a pair. So if let snailfish number pair left hand side right hand side equals self if level 3 is greater than 3, then how do I assert that it's a scalar? I forget how you do that. I guess we do it with a match, right? Match left-hand side. And here we go, mechanic. I guess I can just call it unreachable. N goes to N. There. Yeah, well, I haven't finished, so to do. Close that. Just started learning Rust. Is the Rust book a decent learning source? So there's three starting points. Hungry Hippo. So if you go to learn dot, was it? I just Google, well, DuckDuckGo in this case, learn Rust. Google search or DuckDuckGo search learn Rust. There are 3 paths. You can read a book, you can do the course, which is like walking you through it step by step, or you can do it by example where you just jump into code straight. Pick the one that fits your learning style the best. I think the book is good, but for me, my education continued after the book. Bar checker is mean. I think the bar checker is mean because the book doesn't teach lifetimes very well, actually, A squared. If I had a lot more time, I would devote myself to writing a book that explains lifetimes better than the book does. But I don't have the time, unfortunately. Suspected a boxed, found a number. All right. Wait, what? What is it not like about this? Do I have to... Hold on, what? Do I have to borrow? Okay, why... When I unwrapped it... Is that not correct syntax? Okay, it's giving me the wrong syntax right away. That sucks. It's like as ref, I thought something, right? Yes. Because you have to do as ref on a box to get to the thing inside. There's an old book called Beginning Rust that teaches lifetimes properly. Oh, there we go. So there's a good book, Hungry Hippo. Because the Rust book that Learn Rust it's pretty good, except for I think it sucks when it comes to teaching lifetimes, and that's, I think most people have trouble because of that. But if there's a book that teaches it properly, then go for that. Save yourself a lot of grief. I kind of feel like I should have a function called like unwrap scalar or something. Anyway, if it's the way we're going to explode is we're just going to return some left-hand side, right-hand side here. If we don't, then we're going to, it's just going to be none. So then I don't really need this sum here, do I? And if it's not a pair, then it's also none. So I can reduce this quite a bit, right? Is it really this easy? No, I have to do more than this. I have to, this has to be expanded because we have to call explode on the lower levels, and if they explode... Well, number one, this has to, before it returns sum, it has to change self. Oh, yeah, that's right. We have to change self. Shoot. Okay. Okay. A squared's going to hate me for doing this, but now it's a really complex type. Because it's got to transform itself into a scalar of 0, right? And some left and right. Oh no! For this one, it's going to call it recursively and then return itself. So yeah, ultimately we just return self and none. Right, but we have to modify explode left, right, then distribute. If it's not a pair, we just return none, self none. So actually then I can remove this all the way out and drop this else and this one, right? What's wrong with this one? Oh, this has to actually return that. That's our early out. Okay. All right. The recursive part is easy. We would say let left-hand side and then left-hand side fragments equal, I just realized that we have to distribute this all the way up and then back down. We'll figure that out in a second. Left-hand side level +1, right? And then let right-hand side fragments equal explode right-hand side level +1. LHS dot RHS dot. At this point, the inlay hints are making it possible to read it, so I'll turn this off for a second. Okay, so then what do we do with these fragments? The right of the left-hand side fragment can go into the right. Yeah, we don't want to further it if it explode, right? If let some left right equal left-hand side fragments, then we're gonna do something and then return self. Here's where I might not return none, right? Because we might have fragments to return, actually. In fact, we do. The left has to be returned. So that's some left. And then we might have to actually take the right one out too, right? Let me think about this. No, it should go into the right-hand side or nowhere. Yeah, if it's a scalar, just get added to it. If it's not, it will go into the left-hand most child. So then this would be 0. And I have to put more parentheses around it, because Rust likes parentheses when it comes to tuples. So then this is 0 right, but we're missing 2 function calls here. So it would be right-hand side dot as mute dot distribute right, or distribute left right. And left hand, and then the opposite, left hand side distribute right left, right? Left. Okay, at this point the left hand side has been unpacked, so oh, I can't return self either, can I? I have to repackage ourself. Yeah. I've got to do this. And left-hand side needs to be reboxed. And if we get down here, I think both of them have to be reboxed. And then, yeah, we don't need to do that. Left-hand side does need to be marked as mutable, though. So that we can mutate it down here. Okay. I need to mark these as mutable, don't I? I think so. Because you can only call it as mute on a mutable box, right? Okay, so I just need to, again, just need to. We move the problem to distribution. This one just needs a mutable self and amount. Use size, right? And then the distribute right is similar. And let me just resolve this compiler error before we continue. What's wrong with this one? Oh, yeah. So we can't continue. We have to update number. Just like we did with split. Let new number did explode. Well, this is, we don't care. Actually, we do care. Fragments equal number explode. If, well, number equals new number. If let sum, or just if fragments is sum, continue. There we go. I fixed it. Oh, another error. Can't return self there because we moved it into the if let. So I gotta move it back out. Okay, so then I can't use this convenient return the way we did that. So I need to have something if neither side exploded. So I guess it's just this, right? With a none. And else scalar, or just match, I guess, on this. Like that. Okay, so that bracket, comma, and then snailfish number scalar n just goes to itself. With a none. Okay, severe indentation, but no compiler errors. I guess I didn't need to mutate the left-hand side. Why not? I thought I would need to because I mutated it here, but I guess we own it. So I don't need to mark it as mutable because it goes into this explode. And this we can just do that to it. I need that parentheses though. And there's another warning down here. Oh, part 2. We haven't done it yet. Okay, so let me make sure I got this right. So if it's a scalar, it doesn't explode. If it's a pair, above level 3, it explodes into 2 scalars. And we replace the self with a 0, and the left and the right go out as fragments, right? If it didn't explode, we try to explode the left. If the left exploded, we distribute points to the right, and we reform the left-hand side, which will be a scalar 0, really, with the distributed points on the right-hand side, and the left points go to the left. If that didn't explode, we try to explode the right-hand side, same deal, only we distribute the left points to the left-hand side on the right arm of the left-hand side. And we return that the same way we did before, and the right points go off to the right of our parent. And if neither side explodes, we just rebox the left and the right and say we didn't explode. I think I got it. Could the binding at pattern syntax help me? You mean like with the level? I don't know. I don't think I'm gonna bother, if that's okay with you. So distribute left, this shouldn't be too bad, right? Don't we just do match self? And if it's a scalar, we just add to it. N plus equal amount. Dereference. If it's a pair, then we have the left-hand side and the right-hand side to deal with. And since we're distributing left, we just say left-hand side distribute left amount, right? So I don't need the right-hand side. Don't need these braces probably. Well, that's easy. And then distribute right. Let me see, make sure I got this right. Yeah, we want to follow the left arm, the leftmost arm. So we follow left down. And this one we follow the right side down. It's the right of the right. The right arm of the left. From above us. So it's right all the way down. Okay, should I test it? Are we ready for the fated test? Let's run this thing. Hey, look at that, we passed. So dare I run the, I think I dare. The real thing. Cargo, run 17-1. No, I run day 18, right? We're on day 18, not 17. Okay. But to get the real answer, they wanted us to do one more thing, right? What did they want? They wanted the magnitude. 3 times the magnitude of its left plus 2 times the magnitude of its right. Okay. So did they give me that as an example? That looks different. Yeah, that's a different example. So I guess we're ready to ditch this and add and like calculate it for the real thing. Yeah. I hate ditching this though. What if I redo this to be like, I don't know. I guess we will ditch it. Just in case, let me stage all my things in Git. I could get back to this point. All right, so I'm going to change our test then. Because I can't use this anymore because we don't know what the magnitude of this is supposed to be, right? Okay, well, we'll just change it around then. So the magnitude of that is 29. Magnitude of this is 143. I'm bummed that well, we're just doing this step by step, right? I shouldn't be bummed that I'm getting rid of getting rid of the old examples. We can't use them anyway, right? I should be happy that they're giving us more things to test. That's what I should be happy about. 445, because we have to add another operation. How many more are they going to give us? 3 more. 1, 2, 3. 1, 2. Could write a separate magnitude function and add another assertion to existing tests. I could, but like the tests we had, now that we've proven that it's working, probably are useless. I say probably because like I haven't tested with my actual answer, but we really can't anyway because we can only test it by putting in a number here. We can't put in the snail fish number. So I would need to do this part anyway for the real answer, right? Oh, and they have a really long example. with multiple lines. 4,140. Okay, so then let's add that last part. So it's after unwrapping, we want the magnitude. Then go to string. So magnitude, and we can actually completely consume the number here. Magnitude self gives me a number. Match self. Okay, how does magnitude defined? 3 times the left plus 2 times its right. Okay, magnitude of a regular number is just that number. So n goes to n. Pair, left-hand side, right-hand side, is 3 times the left-hand, so left-hand side dot magnitude plus 2 times the right-hand side. That wasn't too bad. Let's try it. Run that test. Pass. Easy. 4,033. I'm confident. Yeah, we got it. All right, on to part 2. That was part 1. That took me 1 hour and 21 minutes. All right, you notice a second question on the back of the homework assignment. What is the largest magnitude you can get from adding only 2 of the snailfish numbers? Note that the snailfish addition is not commutative. That is, x plus y and y plus x can produce different results. True. Again, considering the last example assignment above, the largest magnitude of the sum of any 2 snailfish numbers in the list is that. This is the magnitude blah, blah, blah. So isn't that just doing a combination of all of these? So we collect all the numbers and we do a, well, permutation, right? Don't we just do a permutation? Pick 2 of that in any order and just find the maximum. So isn't that all we want? Let's try it. So they gave me this example. Line it up. They said it was this number. This doesn't seem so bad, actually. I don't care if it takes a little bit of time. I don't think it will take a whole lot of time. I could be wrong. This might be like the other day we had one where brute forcing was impossible, and you had to... So combinations explode quickly, oh no. So am I leading myself down a dark path of taking it forever to compute it? Is that what you're saying? Let's see, but the brute force should work with the small example at least, right? So let's start with that. I want to collect these then into a vector. And let's say that those are our numbers. Okay, now what do we do with these numbers? We want to pick one. So for x in 0 to numbers.length, for y in 0 to numbers.length, and I know you're screaming order n squared, and you're right. Let mute largest equals 0, largest to string. All right, just bear with me. What's wrong with this collect here? Oh, I don't want to reduce here. We're not exploding then, right? Oh, interesting. So we're not exploding or splitting at all. We're just collecting them and finding the largest. We can skip... we don't add it to it. We don't... Oh no, we still need this because we're going to do this once. So let me just comment it out for a second. Or you know what I can do? I can just take that logic and make this the add function of two snailfish numbers. I'll do that later. It's really this, right, that we need. Do we try adding it to itself? Any two. So I guess we don't. So if x equals y, continue. Let the number equal that. What's wrong with the accumulator? Oh, it's just right. I'll need to clone these two. So numbers x and numbers y. It's going to complain until I clone them, right? Can't move it out, right? So we're going to clone them. Actually, can I just borrow them? I can't though, right? Because a pair has to own it. Okay, I'll take the clone hit. Take the hit. Clone it. You can clone it. All right. It's good. We're good. And then we want the magnitude, right? Of the sum. So that's largest equals largest dot max number magnitude. Okay, how bad could it be? How bad could it be, you say? It could be pretty bad. Let's see if I got the answer for the test at least. Yeah, okay. So how you think it'll actually end before the age of the universe is over? No, it actually got an answer right away. Easy. Brute force for the win. We could probably make it faster, but I don't care. I got the answer. Why brute force it when it runs in a good enough time? Let's bench it. Because I can. It seemed pretty slow, but it was a debug build. Maybe release build would be a little bit faster. But I bet the performance is going to be miserable, like over a millisecond. I'm going to say like 100 milliseconds at least. Oh, yeah, it's bad. It's really bad. It's going to take 47 seconds just to do it 100 times. Greatly overestimating the complexity. You're thinking factorial because you're thinking, no, it's just order n squared. Right? So there's probably some insight into the problem to reduce the order to log n or something, or n log n, but I don't really feel like doing that. You guys who are better mathematicians and algorithm designers than me, you guys feel free. I just wanted to see how bad it is, and see how I did on the leaderboard. Let's see. It told me the rank I got right away. That's new. Did they do that before? Oh, it's 500 milliseconds. Yeah, pretty bad. I don't think it did that before. Stats. No, leaderboard, personal stats. I don't think I did very bad. I think this was just a harder one for people, right? Top 1,000. I'm happy. Why write a parser when it's a JSON already? I didn't think about that. For Rust, I would have to pull in this serde JSON crate, right? Yeah, so someone working with a language where JSON is a native type, like JavaScript, probably had an easier time with this. Where did I spend most of my time? I spent a lot of my time hard. I guess I have to go back in the VOD, but I spent a bunch of my time figuring out the rules, really. Explode took a while, and split was pretty fast. Let's clean this up, actually. I want this to be cleaner, because this logic about adding really belongs inside of a method of small fish number. So isn't there a trait where we can just use plus? Isn't it like add? There's an add trait. Yeah. So why can't we just implement add for snailfish number? Let's do it. Let's implement add. Output is another snailfish number. This is add. So this is self. And this is right-hand side. And when we get out, we return what? Number. Easy peasy. So then part 1 is just accumulator plus next. And then this one is just numbers x clone plus numbers y. So let's just do this plus shoop. It doesn't need to be mutable. So then I can just put that directly into here. Well, no, let's leave it out. It's easier to read that way. Just make sure I didn't break anything. Nope, nothing broke. Where is that warning? Oh, the warning's probably day 17. Yeah. All right, never mind. Okay, that's nice. We've hidden away add into implementation of add where it belongs. So I could go down the route that you guys wanted me to before and use result or some other type rather than having it return an option or a boolean, maybe. That would clean it up some. I think I'd want it to have like explosion result or something. Okay, I can't really do that with explode because it's not one or the other. It can actually the two possibilities are the self plus nothing and the self plus a tuple. So there's always the self there, so that doesn't really work with the result unless I have result self, comma, self, and something else. The other one, though, split. How is that used? Well, isn't it the same problem? It's that I'm transferring ownership back out plus some additional information. It's not alternative. This is not an alternative thing. Use the discriminant of the enum as the sum none and have the shared data. It would just have to be in both variants. Then I don't like that idea of having it in both places. I like it having it in one place and then having the other piece of information next to it. So actually I prefer the tuple, or if we want to formalize it, just make a type that is like the split result, and the split result has the modified number in it and then indication of it if a split occurred or not. And I use that indication to know when to continue trying to split, right? Yeah. Yeah, because we only want to do the operation once, and then because we might explode after that. Yeah, so I think it's not an alternative situation. We're adding information, and the wrinkle is that I have to. The way I structured this, it has to consume self and then pass it back out because the number can transform itself between a scalar and a pair. In Split's case, some no change self could convey a meaning any but then I don't like the idea of having self in both alternatives. That's the thing. Is you could ignore the bool and use the self however you like. Yeah. Well, a caller might not care if it actually split or not. In this case, it did only because they gave me a rule that said it had to. Right? But if they didn't tell me this rule, I might not have cared at that point. I maybe would have cared here. I don't know. I don't know. I guess I'm just not convinced. I should just go back to day 17 and finish that. I have to, like, get my brain back into day 17 mode here. Where's the screen? Here it is. Back to day 17, which we haven't gotten. We're going to get a greater than 24 hours answer. That's okay. Oh, this one, yes. Didn't I, like, almost have a solution? Because I had it, like, yeah, I had it giving me, basically it's iteratively finding, almost brute force, I guess. Maybe it is brute force. What I want to get out of this is the last hit. That's 9. And then just get the maximum of the last hits. 9, 1, 0, -1. Okay, if it can't get a better hit, maybe we stop early. Right? It's always getting worse, right? Yeah, it's never getting better. It's always missing. Okay, so then it is going to just be the first time that we actually hit, like, the least amount of x initial velocity. It'll be the highest y velocity we can actually hit it at, right? So I would just stop early. If we get to here, we want to break all the way out of that, I think. Well, we still want to do this. I want to find the last of that. So to do it like here, right? Let last IV equals 0. Just do this. I hate this. I hate putting an initializer there, but yeah, just because my brain's fried at this point. Ivy. And then we would just get our answer here. The whole point was to get those two numbers right. So here we would just return format IVX and last IVY. And then this is unreachable. Right? Let's see if I got it. Yeah, okay, we got it. Oh, they wanted the maximum Y position. Shoot. Okay, so they want a slightly different number, 45. Well, then I just change this. Highest Y. Let me think about this. Yeah, because that will, that breaks us out of that loop. Oh, right. I need to reset this, though. So, like, highest Y this round is Y. Let's make this 0. Doesn't really matter. And this would be that. No, not there. It's here. Is that max Y? Yeah. And then when we return at, when we get a hit and break out, why? I'm continuing. Why am I continuing on? I don't know why I am. Oh, right. There's an early return. That's why. Okay, so then this highest Y is when it breaks out of here. Right? Yeah, I go much slower when my brain is fried. So it's just highest Y to string. Alright. Brain slow. You take hints for day 17? I don't think I need them. Uh-oh. It's 55. 45. Wait a minute. Oh, right, because, no, this is correct, right? Oh, no, wait a minute, it continued? Why did it only get 45? Why did we get 55? Hold on. Oh, shoot, it's... I only want to do this if it hit. So, if it hit, else that... There we go. It got higher, but it missed. Still wrong. Shoot, what am I doing wrong? This variable is going to be its high point, right? And if it hit, it'll add that to there. Oh, this is backwards. That's why. Yep, got it. Brain fried. Do I have input for 17? I don't know if I got it. Oh yeah, I already did, right? That I actually just baked in because it was a single line. I'm like, why bother parsing it when it's just given to me? Right? So just cargo run 17.1. So it's 55. Gosh, I hope it is. No. Please wait 1 minute. It didn't tell me if I was too high or too low. It's not 55. What did the actual output give me? A whole bunch of things. Miss, 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 and then, oh, we hit something. Maybe it's ending too early. Maybe I should have it continue. So yeah, the highest... Now where does it actually hit? It hits here. Maybe I do need to have it continue. So, because I thought maybe I could return early, but maybe I can't. So rather than returning there immediately, I guess I'll just take this out one level. Actually, all the way out, right? All the way out to here. And then just return this. This is 0. Okay, let's just try it. Well, I can try the test to make sure I didn't break it. Yeah, it still works. Okay, so do I get a different answer? It's gonna try a lot more tosses. No, it still gives me 55. What the heck? Stops giving high-low hints after a few guesses to avoid binary search. Oh, I see. Because I could just get it pretty easily by going high-low. Okay, then what did I do wrong? I really don't know. Output text. Let's look at the output dot text. Hit. When it actually gets the answer, what does it say? Hit Y or something? Hit XY. Hit XY. Should probably have it say what the highest was. Y max. Highest Y this round. Y max. This is because it starts at X0, right? No. Wait, what? Oh, because they're all negative. Yeah, these aren't gonna count. But here we go. Actually, I can see the yellow there. These are all gonna be zeros. The last non-zero one. I think it was there. Nope. There. 55. Is it, so it's the first group. No. There's a second group. 55. I don't know. Actually, it stopped at 10. Wait a minute. Wait a minute. Wait a minute. That was an artificial limit that I put in there. Yeah. Okay. Then I screwed this up because I forgot about that. I had a 10 in there. Let's just run it again with 100. And look at the last line. Actually, it's not going to show me in the last... No, it does. 3,916. But let's look for that number. Make sure that it's not a... So that's at 88. Okay, that's probably the right number. Okay, now I feel dumb. Too low? It's the right answer for someone else. You might be logged into the wrong account or just unlucky. Really? That's our puzzle input. Let's check. Let's double check. It's someone else's answer. 179 to 124. And is that inclusive? I don't know. Too low, though. No, but I looked for that number, and like it tries at the higher initial Y and misses. That's the highest, right? I don't see it. I don't see it hitting that 100 limit anymore. Okay, those are all going to be misses. Now, is it inclusive? 10, 9, 8, 7, 6. Yeah, it is. So, what did I do wrong? I'm not cheating. Get my puzzle input. It says it's that. Paste it to there. Whoops. Those numbers there should match there, and those numbers should match there. It looks to me like they do. I mean, I could look at the output here and see... So initial velocity either of 13 or 12, it says. Yeah. 13 or 12. That's interesting. There's a region where we actually miss a few times and then we start hitting again. Am I starting at 0? Yeah. Starting at 0, 0, 0. Starting at 0. So I know that this 100 is plenty because when I look at the output, we start to miss. I guess I can go up to 200 just to double check, right? There's no harm in that. It'll just take twice as long. And then look at the last line of the file. Oh, wait a minute. Wait a minute. Did it say I was too low? Wait a minute. Hold on. Do we have a whole bunch of misses and then start hitting again? Oh, we did. Oh, look at that. Okay. So should I go to 1,000? So 15,931. Has it been a minute? Just try that number. Okay. That's weird. There's a whole bunch of misses and then hits again after 100. How am I supposed to know this? Like, it hits and then we're increasing our Y velocity and it misses a few times. Oh, but then it hits some more. And then it looks like we get the highest we can shoot without, like, going, you know, having it go too fast on the way down. But then it starts hitting again. How am I supposed to know that? You went to 1,000, but less is enough? Yeah, there must. I don't know the way. I don't know the way to properly solve this problem. Let's just remove it and call it a day. I don't like this. I don't like that day's problem at all. It's too much guesswork for me, and I'm just not smart enough to know how to solve it correctly. There's probably some clever way to figure it out that I just don't have the patience for. I don't need that. No, we haven't done part 2 yet. Oh no. I have to do part 2 still. Part 2 is probably going to be horrible, right? Passes, and then I can run this without piping the output and get the right answer. Okay, let's move on to part 2. Sigh. The highest Y start velocity is Y minimum. Yesterday you brute force, so you went to sleep. You remember triangular numbers, had to get up and try it. The damn answer is some range absolute Y1. Huh. I don't think I would be able to figure that out. There's some interesting scatter plots of this one. I'm sure there are. Rocket went in a spiral. It must have clipped the corner or something, and then as we increase the height, it then clip the other corner? I don't know. I have a hard time even visualizing it. Highest point is when velocity changes direction. Sure, it's... Oh, right. Yes. So I could just see when the sign flips to the negative, and then I know what the highest point was. So someone came up with a closed form solution, but brute force was enough. Yeah, so I guess we'll just go with brute force. Maybe a fancy trick shot isn't the best idea. After all, you only have one probe, so you better not miss. To get the best idea of what your options are for launching a probe, you need to find every initial velocity that causes the probe to eventually be within the target area after any step. For example, there are 112 different initial velocity values that meet these criteria. For what? What target? Do they mean for this example target? Is that what they mean? I'm gonna guess that that's what they meant. They didn't say it though. Okay, fine. So then we'll just do test part 2. And we want the number 112. But I guess we're assuming the same test area, right? So I'm assuming that I just do my brute force again and I just count the number of times we hit. I mean, why not, right? Oh, wrong place. We need a target. Need that. There, and this here. Okay, so we don't need the highest Y, we just want the hits. And then, if we hit, we hit. Hits plus equal 1. Hits. Right? Because with brute force, I'm hitting every spot anyway, right? No. We only got 45 hits. So, what am I missing? Oh, I think we're missing the ones where we shoot directly at it. Right? All these ones with very large values. And I excluded those at first, right? Yeah, so hold on. Let me think about this. Didn't I divide by 2 somewhere? Need some different bounds? Yeah. It might be this one. I think it might be that one. What was the test bound? -5? Yeah, that's definitely wrong. So what if we just do start? I think that's right, right? Now we're shooting and we can hit the bottom in one hit. No, it's still 45. I don't need this highest round either. Oh, don't I need to break out of that? I'd break out of this. Oh, thank you for the follow. I don't think that'll change my mistake, though. Still 45. Okay. Oh, wait. I've done this once before this year. I'm calling the wrong test number. Okay. It is getting the correct number. All right. So now I feel stupid again. That can't be right. It got that answer far too quickly. And it is right. Okay, then. Well, I didn't like that day. I felt like I was literally shooting in the dark. Right? Because that whole day was about... How do we get back to that day? That whole day was about shooting at a target, and I just went brute force on the thing. How fast or slow is it? So, benchmark... I'm going to guess it's terrible. The performance is terrible. But I'm not going to care because I didn't like this day. Oh, I'm being rated. Ironista, hi. I just solved day 18 and then 17. Day 18, I got a pretty good time for me. How was your stream? Yes, fancy meeting you all here. It's like we're all working on this together, sort of. Leaderboard, personal stats. I got sub 1,000, which for me is pretty good. I'm a slow coder. 18 was complicated? Yeah, it was. Like, I was surprised I got sub 1,000 when it took me an hour and 20 minutes. Part 2 was easy, though, because it was just a little twist added on to part 1, I thought. But yeah, it took me... And then I didn't do day 17 yesterday, so I had to catch up. So, but I would have gotten a terrible rank, I think, anyway, even if I did it on time. Because this day 17 one, I just couldn't think of a clever way to do this. So I just, through trial and error, found the right ranges of X and Y velocity. And part 2 is literally just counting the number of times you hit. And part 1, I just had to do some, like, find the peak, right? So the maximum of all the values was good enough. Someone pointed out that I could just wait until the velocity goes from positive to negative, and that's the peak of the curve. But yeah, it's the same thing. Really wanted a principled approach? Yeah, same here. I was like, I can't think of a deterministic way to solve it. Someone in chat said that someone has a deterministic solution that doesn't require trial and error within ranges, but I can't think of it. So anyway, why don't I just go over my solutions and you guys can see how I did it in Rust. So we'll just do day 17 first. So usually I like to take the examples they give in the problem description and make those unit tests. And this is like the standard way to do it in Rust. Especially with Rust Analyzer, you can just do run tests and it's automatic. I don't even have to have a shell up when I do that. And then I broke running the tests into an inner and an outer. So the inner can be used by the unit tests and the outer works off of the actual test input. So for day 17, it was just a single line. So I'm like, why bother parsing it? I'll just type it in myself, right? Usually on these puzzles, you can't just type it in. There's a lot of text. So I would have it as included as a string, and then I'd have some parsing, but didn't need to do it for 17. But since they came in as ranges, I felt like that to be true to Rust, I'd use range inclusive, which it was a little bit awkward because you have to call methods start and end, and you have to dereference them because you're borrowing the start or the end of the range. But whatever, right? Part 1 was about finding the highest y coordinate, and this is just a brute force solution. You can tell it's brute force when you have nested for loops. And then you even have a while loop inside, so it's really three nested loops. Ugh. Day 16 part 1 is y times y plus 1 divided by 2? Really? I don't remember what was day 16. Are we talking about the same day? Day 16 was the decoder one. That was fun. Do you mean... Oh, day 17. Okay. It is y times y plus 1 over 2. See, there's no way I could have come up with that. My virtual hat is off to you for either coming up with that or whoever did come up with that. Anyway, so the brute force stuff is pretty straightforward and gross and procedural. So there's no clever function chaining here. We're just accumulating. That's why we have all these mutts. This means that the variable is mutable. So we're going to be changing it as we iterate. So for every initial velocity of x I found like the bounds that I was comfortable with. Like we can't go lower than 1 because then we won't go anywhere. So go from 1 to hitting the target on the x coordinate, the first step, right? If we go any faster than that, we'll never hit it. So that was the obvious range for the initial velocity of x. So I thought maybe I could split the velocity of x guess from the y guess, and it sort of worked. So we first make a guess for x, and I think I ended up not needing to do this. I could probably delete this. I think this is just like my attempt at doing an optimization. I could probably delete all this stuff. But anyway, this was to see, if we just look at it one-dimensionally, will we hit the target, right? So we just do a simulation here. We start at x is 0. We have the velocity equals the initial velocity, and then we say, while we're to the left of the target and we're still moving, we move a little bit, and then this is the drag feedback, right? And so eventually we'll either stop or we'll hit the target or we'll go beyond the target, right? And this is the check to see if we hit the target. I think I had that in there for some reason. Why? I don't think that actually needs to be in there. No, that needed to be in there for some reason. What was it? I don't remember. Why do you check X at all in part 1? I think this is just an optimization. I could probably drop it. It would still work. So maybe disregard the highlighted part. So anyway, given a guess for the initial velocities of X and Y, we just run the simulation completely with X and Y, right? And then here's this highest this round is just seeing what the peak is for this test. And we're just doing a simple maximum. I could have checked to see if Y goes from positive to or 0 to negative, and then we would have said, oh, okay, then we'll that's the highest point. But I just kept it simple. And then we stop if we ever hit the target. If we hit the target, we do that. I probably could have moved that into there now that I think about it. Right? I probably could have just moved that into there and then don't need this anymore. We can run our unit test to make sure it doesn't break anything. Yeah, it didn't break anything. Run 17.1. Make sure I get my original answer. 15931. Yeah, that didn't break anything. Good. So this is why we have unit tests. So yeah, this is like pretty much brute force. It should be not too hard to understand, even if you don't know Rust. Some of the characters might look weird. That's just because in Rust there's a distinction in types between values that you own and the values that you borrow. So like the contains is a method on this range type, and the contains method, if I click into that, see how it says like that, it means it's gonna just borrow that item to see if it's contained within the range. So we have to borrow X. If I just did that, it's gonna complain saying consider borrowing here because it expected a reference and you passed it a value. So weird stuff like that. This is how you do ranges, by the way. And that means it's inclusive. If I got rid of that, it's exclusive, so it does not contain 200. There it contains 200. How I come up with this number is very ugly trial and error. What else can I explain about this? Not much. Contains, it works for ranges. Max just takes the maximum of the value and some other value. ToString turns it from a number to a string, just so that I can make it, just conform it to all the problems I do this year returning a string. Borrowing is a new concept for you. You're new to Rust. Yeah. Borrowing is one of those concepts that the book that most people read about Rust, the Introduction to Rust, doesn't explain very well. But if you think of it in terms of who owns a value, it becomes, I think, much easier to understand. So we own any value that we declare. And when you call a function, you own it if it's not a reference. But you might start to split hairs because technically we own the reference. We don't own the thing that the reference is pointing to. It's different than in C and C++. You don't care at the compiler level who owns what. It's just, is it a pointer or is it not? In Rust, at compile time, attached to the variables in your program, the compiler remembers who owns the values. And so it keeps track of, like, if you're just borrowing the value and you try to borrow it too long, you get a compiler error. We own the pointer, but not that long day. Yes. In C, it won't even check to see if the pointer still makes sense. In Rust, it's very strict, and it will, unless you mark stuff unsafe, it will be very strict about making sure that no pointer that you have can point to anything that you freed or was on the stack and got popped off. The benefit is that you catch errors at compile time if you can the syntax and you can wrap your brain around it. So it's a cost benefit balance. More thinking and getting used to the syntax goes into it, and what you get out of it is the compiler does. If it can pass the compilation stage, then you're pretty much guaranteed not to have any memory leaks, no race conditions in threading, and no aliasing of pointers. Right? You can't have two pointers that accidentally point to the same thing, and oops, you change one when you're not supposed to be able to see a change from the other. Like, that's not possible unless you turn off the safety features, which you have to when you're doing like kernel level stuff or at the metal, no runtime. You can do that, but when you keep the safety features on, the compiler does a lot of, through type analysis, it figures out a lot of these common mistakes for you. But the cost is you have to understand and deal with the extra syntax required to tell the compiler what you're doing. No read after free, no buffer overflow. Exactly. Like, I don't have it in this example, but when you have like arrays, there's automatic bounds checking for all arrays. So the cost is that it's maybe a little bit slower depending on the type of array. It has to check if you're out of bounds or not. The benefit is that you'll catch right away if you go out of bounds. So let me show you what I did for part 2. It was basically part 1, except for that we just counted the number of times we hit. So I'm actually not really proud of day 17 because it was brute force and procedural. Let me show you day 18. I was much happier about this one. And this one has some more interesting things in Rust anyway, right? So day 18 was today, and that had to do with snailfish numbers. Basically a data tree where a node can either be a complex node with 2 children, or it can just be a leaf node. I modeled it as scalar or pair. And one thing that's interesting about this in Rust is if I remove this box thing here and did it like you might expect that you should be able to, Rust is going to say, oh, wait a minute, that's an infinite size structure. And if you think about it, it is infinite size if you understand how enums work. So the way enum works is like a union in C, where the size of the type is the size of the largest variation or variant. But what is the size of this pair? Well, it's 2 times the size of itself. So you can see how it's technically infinite, because if you have to allocate enough space for either one of these, the size of this is double the size of itself. So what box does, basically it's the same as an owned smart pointer in C++, like a shared pointer, like a unique pointer in C++. We own a pointer to this value, so the size of this is just the size of a pointer, right? So the size of this variant is 2 pointers. The size of this is a U size, which is size T in C. The benefit is is no longer an infinite size type. The downside is that there's indirection, right? When you see box in Rust, think pointer to something on the heap. Now, the pointer is guaranteed never to be null, but on the other hand, you always have to dereference it. You have to allocate it. Well, it allocates it for you, but you have to kind of carry with you the knowledge that there's going to be some weight there, some cost in allocation and dereferencing and all that stuff. Anyway, that aside, we're implementing from string. What that lets you do is call parse on a string and get you a snailfish number, which is pretty neat. You just have to say how it's implemented. So what I chose to do is say, well, we need to find out if it's a scalar or a pair, right? If it doesn't match this pattern, then it's a scalar. The pattern is that the first character is a open bracket. So if the first character is not an open bracket, then it's a scalar. Really easy, right? We just take that string, we parse it, because usize also implements from string. It can fail. Unwrap means that if it fails, then crash. So in other words, we're saying we expect it not to fail here. If it does, go ahead and blow up, right? It'll only blow up here if we gave it bad input. Advent code never gives us bad input, so I'm just being lazy here. In a real program, you do something like check to see if there's an error. If it was, maybe you'd pass the error along to your caller, or maybe you'd log it or something like that, right? Anyway, matches is kind of cool because this pattern can be kind of complex. We're saying that when you take S and iterate its characters and take the next character in the iteration starting from the beginning, so in other words the first character, that it is some character, and if that character is an open bracket, then it matches. Now take the not of that, right? So either there is no character at all, or there is a character but it wasn't an open bracket. Well, then you have a scalar. So return early on the scalar. Otherwise we're dealing with a pair. This is a statement saying we're always going to fail. Always going to succeed. We're always going to succeed. We're required by the interface from string to have two possibilities. Basically, result means you either are going to return this self type, this is a shorthand for the type we're in, or we're going to return an error. And I decided there is no such thing as an error for us. We're never going to return an error. We're going to crash if we would have had an error. Never do this in production code. Unless you know what you're doing. This stands for like void in C++. This is like the empty type. Yeah, we're always going to succeed. And this is where I decided that we're going to split it on the outermost comma. So to find out which comma is the outermost, like if you're looking at a string like this, you literally have to count from left to right until you get to 0. So 1, 2, 3, 4, 3, 4, 3, 2, 3, 4, 3, 4, 3, 2, 1, well, until you get to 1, basically. So there's that outermost comma, right? So we do this by whenever we take the string, break it into its characters, enumerate so that we get a position count in addition to the character. Skip the first one because we're not going to count that left bracket. And then for every bracket, add 1 if it's an open bracket, subtract 1 if it's a closing bracket. And if we see a comma and we're at level 0, hey, we found the outermost comma, right? And then unwrap says we better have found some comma somewhere. And that's a position. This is how I split it. This is a way to say, take this string, give me a slice of that string from 1 to that position of the comma, exclusive, so not including the comma. And then from the character to the right of the comma to all the way to the end of the string, -1, because we're chopping off that right bracket. That gives us our 2 halves, and then we box those 2 halves, and we recursively call from string. This is the key to doing any complexity, because it's potentially recursive. We recursively parse the left and right hand parts, make sure that that those don't fail, they won't, and box them and put them into the pair. So that's how that works. Hey there, Larry NY, how are you doing? Just explaining my day 18 code in Rust for admin code. This is writing JSON parser? Not exactly. It's a small subset of JSON. So if you had JSON available in the language that you chose to solve this in, you wouldn't need to write this parser code. You just say JSON parse. It's a good exercise to write. I love writing my own parser. Can't you tell? I love talking about it. Just use eval and then convert it to a tree. Fair enough. So I end up with a tree that looks like this in Rust. So display And a lot of these other methods are going to be recursive. Display is what happens when you print or you format something into a string. So it's kind of like the opposite of from string. So if it's a scalar, we just tell the formatter to format the that character that's inside the scalar. If it's a pair, then we're using the write macro to format a string that has brackets, the two things, and then a comma between them. So the write macro or the print line macro and braces like this invoke the display trait on whatever argument you pass. So that's how the recursion here works. Because left-hand side and right-hand side are themselves small fish numbers, they just happen to be boxed. This will automatically go into the box and then call this display formatter recursively for the left and right parts. So pretty cool with this. This is all the code you really need to convert from the tree back to a string. And this is the add. This is where it gets really complicated. So they told us the rules that to add two numbers, you make a larger number with the left and the right arguments in a pair. And then you have to follow these rules called the explode rule and the split rule. So I just made those functions. And this is probably not the best way to do it, but I decided that explode and split will take the original number and possibly change it and give you back a new number, and then tell you if it exploded what those fragments were, and if you split it, what if it did the split or not. So basically, this is like try to explode the number. If it did, then we're going to try again. Basically, it told us to keep trying to explode until you can't, and then try to split, and then until you can't. Every time you split, you want to try to explode again. That's why we have these continues, and we have this loop with a break only if we can't explode or split, right? And then explode is really complicated. Let's skip that for now. The split is if the number is a scalar and it's greater than 9, then we turn it into a pair where we divide by 2 and we round down and round up to form the left and the right halves. If it's a scalar and it didn't match this rule where it's greater than 9, then it didn't split. If it's a pair, then we have to descend. So we're looking for things to split, right? We ask the left-hand side, can you split? If it did, then we reform the number based off of the new left-hand side in a new box, right? Left-hand side couldn't split, we try the right-hand side. If that can't split, then we just box it back up and return it and say we couldn't split. Explode is the most complicated one. There's where we have to track what level we're at. And if we find a pair beyond level 3, and I reasoned out that it can't be more than 4 because then either the input was already explosive or we forgot to explode. So basically, I could have written this as equals 4, but I like to say greater than rather than equal for this kind of thing. Anyway, the way we explode is we take the left and right hand numbers, and we're saying basically an assertion that they're scalars, and grab the scalars out. And we're going to turn the number into a 0 scalar, and then the left hand and right hand side become the two fragments, right? So that's the innermost explosion. Now, where do those fragments go is how we handle the rest, right? If the pair didn't explode, then we try to explode the left-hand side and the right-hand side, and we have to increment level here. And then we have to check if it did explode. If it gave us fragments, we have to distribute the right fragment to the right-hand side, the left innermost descendant. That's what this means. So go to the right-hand side, distribute to the leftmost tree branch that right fragment, and then form the new number as being the left hand side. We rebox it, the right hand side we mutated, and the left fragment pops out to the next level up, and there's a 0 here because we distributed the right fragment, and then mirror that on the left or on the right. It gets confusing because you take the right fragment and you distribute left on the right hand side, left fragment distributed on the right of the left-hand side. And then if neither left or right exploded, you don't do anything. And scalars don't explode. So if you can grok all that, that makes all sense to you, then congratulations, you understand it. My hat's off to you, because my code isn't the cleanest, I think. They did give us a wrinkle where they said, like, reduce the number to a magnitude value by, if it's a scalar, it's just that number. If it's a pair, then you take the left-hand side magnitude, so recursive call again, multiply by 3, and then take the right-hand side, multiply by 2, and add them. That was just a rule they gave us, right? And so here's where it gets kind of cool, when you can have a function chain where you have functional programming. So the way to read this is like an assembly line. We take our input, which is a wall of text, and we say, give me an iterator where every item that we get out of the iterators is one line, right? And then for that line, this basically says trim the white space off that line. So map the line into the return value of taking the line and calling the trim function on it. Then again, the next step on the assembly line is parse it as a small snailfish number, and then unwrap that. Basically crash if we if the parsing, again, the parsing has to return a result. We can't just crash inside there. So here's where we decide to crash if we couldn't parse. And then this reduce is going to take every line that comes in as a snailfish number and add them together. So it starts with the first two and adds them, and then those go into the accumulator of the next iteration, and then you add the next to that, and so we're just adding them all up. So reduce is the end of this assembly line. It comes to one snailfish number, and unwrap, because reduce will return none if there was nothing in the assembly line, the iteration. Otherwise, it's some result of the last add, right? So make sure we have something, and then we call the magnitude function, turn it back into a string, and that's the answer. Part 2 is just a little bit different, right? They told us, don't reduce it, that we just want to find the combination of the two numbers that gives us the largest magnitude. And I'm like, I'm just going to brute force this at this point. There's probably a smart way to pick the two, but this was fast enough. So I just collect. What that does is, instead of reduce, destroys all the numbers and gives you one output. Collect allocates a new vector, like an array, on the heap, and just fills it in with the things that come out of the iterator. So we end up with like a vector of snailfish numbers, and then we just go through picking two. We don't pick the same one twice, so the two have to be different. And I just add them and accumulate the largest magnitude. I kind of, whenever you see clone in Rust, it means someone was lazy, or there really was no way to avoid a duplication, a copy. I was just being lazy here. So I have to clone the numbers, because where every loop we might pick the same number more than once, and so we can't just consume the number when we add. The add consumes both the self and the right-hand side. So if I didn't do that clone there, where was I? I could show you what happens if you don't. You get an interesting error message here. It will say, cannot move out of index of vector of snailfish numbers. Move occurs because value has type snailfish number, which does not implement the copy trait. That's a long-winded way of Rust saying that you destroyed those numbers that you were only supposed to borrow. You can't do that. You can't move out of a vector. You can only borrow it. So we borrow it long enough to call clone method, which, as you might think, just creates a new number that has the same value as the one we borrowed out of numbers. You mentioned that implemented the add trait to allow A plus B to work. Oh, I might have skipped that over. Yeah. Where was that? Oh, right here. Oh, yeah, that was the key, one of the keys to part 1. So I did explain this, but I can explain it again. So add is you make a larger pair out of the two numbers, and then you run the explode split rules over it to reduce it back to a stable, non-explosive number. That's what add does. So like the day 17 stuff, I just picked the stuff out, the examples out of the problem description, and made that part just part of the unit test. both part 1 and part 2. And I also made a bunch of unit tests for my parsing and the display trait stuff. So here's where we say, like, if we take the string 42 and we parse it into a snailfish number and we crash if it can't parse, if it didn't crash, it had better be this snailfish number. What's cool about Rust is that it's trying to, well, it encourages you to not repeat yourself with the types. So I didn't have to say, like, parse this as a snailfish number. I could if I wanted to, right? It won't give me a compiler error, but it doesn't need me to tell it to parse it as a snailfish number, because the only way that this type would make sense in a comparison with a snailfish number is if itself was a snailfish number. So there we go. Don't need to say what to parse it as. That's called type inference, and you'll see that a lot in Rust. Some people hate type inference. Like, for example, I didn't say what type number was, but there are a couple ways around that. If you have an editor that has a extension that understands Rust, you can just mouse over it like this, and it says, oh, it's a snailfish number. Or you can type in, or you can turn on inlay hints, and then it'll show you what you would have typed if you wanted to pin that type down, right? Declare it like explicitly, the same type that is implied by the context. And these inlay hints are actually kind of helpful when you're learning Rust, or when you're coding and something complex like this. You can see along each step, like, if you have any bugs in your types, right? Like an unexpected number of borrows, or you forgot to borrow, or something like that. Yeah, so that's it. I think I've explained everything, and I need to end the stream soon because I need to get up early tomorrow. It's a Saturday and I have to get up early. I hope you guys enjoyed the Advent of Code, and hopefully I didn't put you to sleep. Or maybe you wanted to go to sleep and I helped you, in which case I'm glad I could help. Let me find someone else we can go hang out with. Probably I'm the last one that I know to be solving this. Yeah, I don't see anybody else. There's no one else. Hey, maybe I'll just hit the browse and go to the new creative category, software and game development, and see if someone who I don't know is doing Advent of Code. Oh, there is. Lukey is trying out today's Advent of Code for an hour or so at midnight again. And make sure that they're still working on it. Okay, I got an ad. Okay, hopefully Lukey is still going. Set up this raid. Thanks for going through this, really helpful. I'm glad that you find it helpful. I appreciate the feedback, actually. Even if you're like, I didn't really like that, I would still appreciate it if you told me. Okay, so I will see you guys tomorrow for day 19. Please enjoy Lukey's stream. See ya. Bye.